Welcome to The Scanner School, a podcast dedicated to the scanner radio hobby. Class is about to begin. Here is your host, Phil Lichtenberger.
So welcome to Scanner School. My name is Phil Lichtenberger. My amateur radio call sign is W2LIE, and this is Scanner School, a podcast where we teach you everything that you need to know about the scanner radio hobby. I want to thank you so much for joining me today. If this is your first time listening to the podcast, welcome. If you are a returning listener but haven't yet done so, please subscribe to the podcast. It's very easy. All you got to do is take the device out of your pocket and click on subscribe. If you are a web-based listener, and I have to admit, I am a web-based listener of many podcasts myself, just go to the subscribe tab on the website. Very easy. On the right-hand side, you'll see subscribe to our newsletter, and that will remind you every week of something that we have coming up, previous podcasts, or also what's coming up on future sessions. So again, if you subscribe to the podcast and are not members of our newsletter, I invite you to do so as well. And of course, you can always find our latest podcasts and all the archives on our website as well at scannerschool.com. This week's session again is session 42. And you'll be able to listen to this one again and get all the show notes at scannerschool.com/session 42. So before we start, again, this podcast is sponsored by East Coast Pagers. Now, East Coast Pagers, in all transparency, is one of my online companies. Now, East Coast Pagers is a Unication, Apollo, and Swiss phone dealer serving the U.S. market. And we have one-way pagers, alphanumeric pagers, voice NP25 pagers. And we got you and your department covered. So let me tell you really quick about the current Unication promotions that are going on through the end of the year, for the end of 2018. So you get $50 off a Unication G1 pager. If you purchase 20 or more G1 units, you can get the free extended warranty that extends your warranty from 2 to 5 years. And if you're in the market for a Unication G5 pager, they are now $100 off. So basically you are buying a G5 at the cost of a G4, which is quite a bit of savings. So don't forget too, all the G4s and G5s now ship with P25 Phase 2 included. And if you already have an existing G4 or G5, all you got to do is upgrade your firmware and you'll get Phase 2 with your pager. No longer are there any upgrade fees to get you into a Phase 2. So all G1 units and G4, G5 units that are shipped from East Coast Pagers will come with a spare belt clip. G1 Pagers also come with a spare set of batteries. We also give free shipping on G4, G5s, and G1s, as well as the Swiss Phone S Quad Voice Series pagers, and we will also take care of your basic programming needs. So contact East Coast Pagers for your best pricing. Contact us directly for your best pricing. Use that contact form, and we'll get you a custom quote for your individual or your department needs. Again, eastcoastpagers.com, eastcoastpagers.com. Okay, so this week we are going to talk about internal station grounding. We're going to break this down into two parts for you. We're going to break it down into electrical and RF. So if you remember back on session number 32, we talked about lightning arresters. This is kind of a continuation of that topic. Yeah, we're 10 sessions now in the future. But if you haven't yet listened to the lightning arrestor topic, I invite you to go back and do so. And you can do so very easily at scannerschool.com/session 32. But with this session, it's a little bit different. We're not talking about so much grounding the antenna or grounding the coax. We're more worried about grounding your equipment, right? And we had to worry about two different things, like I said before, electrical and RF. So the electrical grounding, again, is something you're going to need to look at on a case-by-case basis, region-by-region basis. What works here in the U.S. may not be what is code or best practice somewhere else. And again, I am not an electrician, nor do I play one on TV or in a podcast. So, I really do advise you to seek professional guidance, professional help, or you weekend warriors like myself. Yeah, you're going to go ahead and you're going to do it what needs to be done. So what are we looking at when we look at internal station grounding? Well, as far as electrical goes, we want to make sure that you have a properly grounded service coming into the house, which means you're going to want to make sure there's a ground rod tied into your electrical panel, but also the outlet that you've plugged in your electronics to, at least in the Radio Shack whether it's your ham shack or your scanner listening post, or whatever it is you want to call it, that they're properly grounded. Just because you have a grounding receptacle, I mean, in a case here in the U.S., you have a 3-prong outlet, does not necessarily mean that you actually have a grounded receptacle, because you could have certain individuals, like myself, who, when they first moved in the house, they swapped out all of their 2-prong outlets for 3-prong grounded outlets, and even though that the outlets aren't truly grounded. The reason why I did that, like many of other people have done that, is because when you go into your Weekend Warrior store, that's basically what they sell on the shelves these days. Secondly, I did it because it was more cost effective for me to swap out all of the outlets in the house when I was repainting everything when I first moved in. Gave me an opportunity to investigate what was behind the wall, at least in the outlet box. Some scary stuff in there, I might add. Nails going straight through the metal enclosure. But it was also easier than going out and buying a box full of those adapters that allow you to plug a 3-prong device into a 2-prong outlet. So it's part of the reason why that I swapped my stuff out. Now, I'm not making excuses here. I'm just telling you that's what I did. You might have a previous homeowner that did exactly the same thing. Is it wise and smart to do? No. But people do it, myself included. So just because you have a 3-prong outlet doesn't necessarily mean you have a grounded receptacle. One of the easiest ways and the safest ways to test is to go out to your local Weekend Warrior facility. I don't know, for some reason I love calling it that. But it could be, your Home Depot, your True Value, your Ace Hardware, Lowe's, whatever it is that you prefer going to. At least here stateside, that's what the companies are. I don't know what you guys have over on the other side of the outside of the U.S. But here, those are the big chain stores where you can go and get some stuff for your Weekend Warrior projects. That's just kind of why I call it that. And you can get yourself a receptacle testing adapter. Basically, it just plugs in the wall, and it has 3 lights on it. It'll either tell you if you're wired up correctly. It'll tell you if you have an open neutral, an open ground, an open hot, and I believe if your neutral and your hot are reversed. I'm not really looking at one right now, but basically that's what they do. And also they may have a button on top so you can test out the GCFI outlet. If you push that button, it creates a short, basically, and it should trip that outlet. So I think most of them have that as well these days anyway. But you should be able to plug that into your receptacle, and it should tell you that things are wired correctly. If you have things that are wired correctly, beautiful, you have a grounded receptacle. If you have an open ground, you don't have a true electrical ground in your shack. So that would be something that you would need to take care of. Now, again, I would advise you to seek out a licensed electrician if you need to have a grounded receptacle installed. But again, you can open up a book, do a Google search, find out how to do it yourself if you don't want to do that as well. I'm not advocating that. I'm just saying that people do what they want to do when it comes to doing certain things. All right. So that was electrical grounding. Pretty simple, pretty straightforward, right? That's really kind of what you need to worry about. Just make sure that, things you plug in the wall are grounded. RF grounding. So let's talk about why we want to ground our station. We want to ground a station because it gives RF a place to go, and you could even possibly, I'm not saying it's guaranteed, you might be able to increase your receiver's sensitivity because you've brought it down to the level of ground. You've gotten some of the noise in your environment a place to go. So if you ground your computer, if you ground power supplies, you ground out other radios, you just give yourself a nice cleaner RF environment to be in. That will also increase the way that your scanners could potentially operate and receive. Now, RF grounding, we can fall into 2 camps here. We can fall under the receiving camp, which is where I want to sit in today because this is the Scanner School podcast, where we talk about receiving, not transmitting. But we're going to talk about transmitting just so you kind of understand the differences here. So there's RF grounding for receivers and there's RF grounding for transmitters. So really quick, let's talk about what happens if you have a poorly grounded transmitter station. Now, we're going to bring these up because, like I said, things are kind of a little bit different, a little bit more difficult in the transmitter world. A couple more extra headaches to worry about. So, again, this is what we deal with on a transmitting side. Now, if you want to ground out your scanner radio shack as if it were a transmitter site, that's best practice. That's actually really great to do. But if not, if you want to cut a couple corners to get the job done, there's some things here you don't have to worry about. So let's talk about what happens in a poorly grounded transmitter station. Well, in a transmitter station, you have to worry about where RF is going to go. And not all of it goes out to the antenna. Some of it could stay behind. So if you key up on a microphone, you might find out when you're too close to the microphone might come out and bite you. It's going to send a little bit of an arc to your lip because you're grounded and the station is a floating ground a little bit. The RF needs somewhere to go. It's going to go and hit you. You might hear RF coming through your computer speakers when you key up because there's extra RF in the environment and it's trying to go somewhere. And you might have heard that too when you had a GSM phone when you're driving around and you might have heard the speaker start buzzing or a little bit of data noise coming through your speakers. That's kind of a little bit of a different thing, but just a way of putting it into context for you. But you would hear like a buzz coming through your speakers when you would transmit. Sometimes you might actually hear yourself coming back to you through your speakers. You might notice if you have fluorescent light fixtures around that they might start glowing even though they're off if you have a high RF environment that you're in. Some other appliances that are in close proximity to your transmitter station may start acting a little funny. I'm not saying that the microwave is going to turn itself on, but you might find out that dials, your power supplies may start acting a little bit funny. You may find out your VSWR meter goes up or down a little bit. Things start getting a little bit touchy when it comes to dials where the RF is getting into those circuitries. You may find out your computer screen is acting a little bit funny. Now, I have fond memories of this happening when I was just first starting to get into amateur radio as a teenager, not really understanding the way things truly worked. And when my ham radio would key up, it would cause my VGA monitor. Remember those old VGA monitors? It would cause the picture to sometimes shrink. The colors would get a little bit skewed on there because the RF was entering into the internal circuitry of the VGA monitor as well. So those are kind of some of the things that happen when you have stray RF in the ham shack. So how do we ground our RF gear? Well, it first starts by having an outdoor spot to sink a ground rod. The trick to sinking a ground rod, no matter if you're doing electrical or RF, is that you have to have a ground rod that is long enough to get through the permafrost of your local environment. So up in the New England area is going to be different than where I am on Long Island, which may be different too than what's down in Florida in a more sandy environment. I don't really know how far down deep you have to go down there, but each area is going to be different. And again, if we're not talking about grounding towers here as much so as grounding just a particular room in a house. But if you want to go that far too, you may want to ground, all the legs of the tower, and you also may want to have some grounding elements, some wire buried in the ground that goes out as a spokes in a wheel kind of thing to allow the energy to dissipate over the ground as well. But going back to getting away from towers again, going back to the simple design here of the standard user with just their RF environment or their single room desk with a bunch of radios on it, the typical user that I envision to be my audience, you basically want to sink the ground rod in the ground deep enough to get down to permafrost. So my neck of the woods my neck of the woods is about 6 to 8 feet. From there, you're going to have to bond that ground rod, and it's good practice, and I believe it's even code in most areas. You want to bond that ground rod to your existing electrical ground rod, and we'll talk about why in a few minutes. So you're going to want to basically ground the two ground rods together. You could use copper wire, or you can use braided wire, or you can use flat ribbon. I guess copper ribbon, I guess is what you call it. If I get off the top of my mind what it actually is. But again, we're going to talk on that in a few minutes. I'm just trying to stay outside the walls right now, and we'll circle back to this in a second. So you bring this RF ground rod into the house, into the ham shack, using the shortest path possible. You don't want to be sticking this ground rod on the other side of the house and running all the way in, right? You want to outside the closest wall to where you are. You want to ground now that ground rod to a single point ground, sometimes known as the SPG, or the Sierra Papa George. Sorry, the Sierra Papa Golf, in proper phonetics. So the SPG, or the single point ground, could be a copper plate with all of your ground connectors on it. It could be a copper strap with all of your ground connectors on it. It could be anything that is in a central located facility that you're going to mount most of your stuff to. That is your single point ground. You can then run wires to your scanners, your multi-couplers, anything in this part of the RF environment can go there. Maybe even if you wanted to, your telco, your cable line. But again, I kind of live under the fact that you want to just have your RF stuff in this enclosure, this box. That's just the school that I belong to, or the church that I go to and what I worship. So everybody does things a bit differently. To me, I believe that your RF grounding should just be housing your RF stuff. So again, from each device, then you want to go to your single point ground. You really don't want to bring, let's back up again. Now, you can have a ground bus or a ground bar on your desk if you really wanted to. That would become your single point ground. Okay? And then that gets bonded to the ground rod. What you're trying to avoid is to have multiple touch points. You don't want multiple elements of the grounding network, because what ends up happening is you could have a ground loop. So let me paint a picture in your head for you here. You have 5 radios on your desk. You have maybe a piece of copper pipe, water pipe that you've salvaged. Maybe it's about a foot long. And you run each radio down to the grounding. This now your grounding pipe, your water pipe, your copper pipe. You run 5 radios using 5 pieces of copper wire to 5 individual points on this water pipe, right? So you have 5 touch points on there, plus a touch point that goes out to your grounding rod. So now you have 6 touch points on there. What could happen in a transmit environment here is you've now created ground loops, right? So each one of these 5 points can create a loop. And these ground loops can then couple in the RF energy and could cause a little bit of chaos in your receive network. So we always try to have a single point ground. This doesn't mean you need to have a giant lug nut, but just try and get all your pigtails into a centrally located bus bar, and then that goes out to ground. You just don't want these things to be too far away from each other, right? You don't want to be able to create loops, but a ground block, a ground bus that has holes cut out for it that you can tie into, that's good. When it comes to scanning and scanners and the grounding pigtails that we normally should be using for our station, really, again, we're talking about receive only here, it should be okay. This is, again, best practice when it comes to a transmit environment. Okay, so let's talk about bonding the ground rod to our single point of contact, or a single point ground. There's 3 different options here we can look at. We can look at solid copper, which is pretty much available at every Weekend Warrior store in your electrical supply aisle. I mean, this is the same wire that you would use to ground your service panel to your lightning rod outside. But there's also a stranded copper ribbon, and there's also a solid copper ribbon. The stranded copper ribbon and the solid copper ribbon are really great for RF shielding and RF grounding. And why is that? Well, because when it comes to grounding RF, you have what's called like the skin effect. And it will go over the surface area of the ground or the copper. And it's very hard to kind of picture in your head, but it doesn't go through the wire. It kind of travels over the wire. It follows the wire. It's kind of like when, I forget the name of it, but like when you're pouring water and the water sticks to the side of the glass and you have to break that barrier in order for the water to drip off. So it's got that surface tension, I guess, is what I could say here. I know there's another word for that, but so really you want either stranded copper, and that's great indoors, or you can go with a flat copper, which is a little bit more money, but that's really great to go from your lightning arrestor to your ground rod, or from indoors to outdoors as well. It's not so easy to work with, but you got to remember to keep it flat as well. The woven copper, that is good to go again from indoor outdoor, because you can kind of compress it a little bit if you had to. But when given a choice to go for from most to least, you want your copper strap, then your braided copper strap, and then your copper wire. So we do have some links and some affiliate codes for some of the things we talked about today, mainly the grounding equipment, the wiring. And you can find links to those at scannerschool.com/session42. All right, so I want to thank our Patreon supporters, Mark Beebe, Kenneth Fowler, MT Bono, and James Felling. I want to thank the four of you again for your continued support of the Scanner School podcast. If anybody wants to help support Scanner School, you can easily do so by going to scannerschool.com/support. Besides being a monthly Patreon supporter, you can make a purchase through Amazon. Any purchase through Amazon using our affiliate link is a way to help support Scanner School. And I have several people out there who are doing just that. I don't know who you are, but I want to thank all of you for going to scannerschool.com/support, clicking on the Amazon button, and then doing your Amazon shopping. We are supporting ourselves through that method, and that is free. That's a free way for you to help support the Scanner School podcast. Also, if you're shopping at ScannerMaster, that's another great way. We go scannerschool.com/ScannerMaster, and that's a great way to make a scanner purchase and help support the Scanner School podcast as well. And I remind you, too, that last week we did a Ask Scanner School. That's where I went into the mailbag and I took out a couple of emails that were getting really old and dusty, and I answered them as a podcast. I want to know what you think about that type of format. I want to do that again next month. So if you would like that, please let me know. Please drop me a line. Let me know that that was something you wanted and you want more of. If you have a question you would like to ask, again, you could always email us, but I suggest using our SpeakPipe or our phone number to submit a question, because that will get you onto next month's Ask Scanner School segment. So just go to scannerschool.com/ask. That's Alpha Sierra Kilo, ASK, and record your voice memo, and I will record mine back to you as a podcast reply. All right, guys, that's it for this week. Remember, everything we talked about today can be found at scannerschool.com/session42. And if you haven't done so yet, you can leave us a review at iTunes. I love reading the reviews that I'm getting from everybody. Scannerschool.com/iTunes. All right, guys, we will touch base with you all next week. 73, thank you all for listening. Again, my name is Phil Lichtenberger. My radio call sign is W2LIE, and this is Scanner School, a podcast dedicated to the scanner radio hobby, where we teach you everything you need to know about scanning and scanner radios. 73, everyone.
Thanks for listening to the Scanner School podcast. Be sure to visit www.scannerschool.com to access the show notes and bonus content.